Okay, good afternoon. So we're looking at the volume of 3D shapes as part of today's lesson, linking it all back to the general topic of car safety. Obviously knowing the volume of different vehicles helps when they're designing the amount of space of it and how that can impact safety. So that's the link to the car safety stuff that we've been looking at. So we're focusing mostly on rectangular prisms or cuboids and on cylinders as part of today. Just a reminder, mostly for the cylinders, because we rely on looking at the radius of circles for that. A radius is halfway across a circle, and a diameter is all the way across a circle. Radius is the one that we use when we're calculating the volume of cylinders, but sometimes they give you diameter. If they do that, it's easy enough, you just divide the diameter by 2. So for example, if this diameter was 10 centimeters, the radius would be 5, okay? So just be aware of that. We want the radius when we're looking at the volume of cylinders, but if they give you the diameter, just divide it by 2, okay? So if we look on this side first about the cylinder, the formula for that is volume equals pi times radius squared times height, okay? So remember the radius is halfway across this circle, so we want to square that, and then we want to multiply it by the height of the cylinder, okay? It's just pi times the radius squared times the length or the height of the cylinder. For the rectangular prism, we want to do length times width times height. They usually just give that straight to you, so just find those and multiply those together. What I'll do is I'll leave those just there for a couple of seconds. If you do want to pause the video at this point and make a note of that into your notes, that might be a good idea. So if you want to pause that. Okay, so I've got some examples here that I want you to try. And again, the best thing for you to do is to probably pause this after I finished talking and then have a go at them. So first of all, we've got a cylinder that's got a radius of 6 and a length of 30. And we've got a cuboid or a rectangular prism with a length of 8, a height of 1, and a width of 5. Okay? So like I say, I recommend you pause this and have a go at working them out. Use the formulas to help you. Okay, let's look at the first one. So for this one, if I just remove the tab hiding the answers. So I've got the formula there. Volume equals pi times 6 squared times 30. We're doing 6 squared because 6 is the radius. So 6 squared is 36, meaning we're doing pi times 36 times 30. And that gives us an answer of 3,392.92 centimeters cubed, rounded to 2 decimal places. Okay? So we use cubed for volume when we're talking about 3D space. Just remember that, we do that as a raised 3 at the end. Then for question 2, so volume equals length times width times height. So 8 times 5 times 1 gives you 40 centimeters cubed for that one. I've got 2 more at the bottom there, question 3 and question 4. So again, you can pause the video, give yourself a few minutes to work those out. When you're ready, just unpause it and have a look at those and see if you can work them out. Okay, so for question 3, the length is 11, the width is 5, the height is 4. If you multiply 11 times 5 times 4, that gives you 220 centimeters cubed. And question 4 is a little bit different. I gave you the diameter of the circle as 8 centimeters, so that means the radius is 4. So we don't want to do anything with the 8, we want to focus on the 4, which is the radius. 4 squared is 16. So putting it into the formula, pi times 16 times 10 gives you 502.65 centimetres cubed, again to 2 decimal places. Okay, so either correct those or tick those in your notes. And the last thing that I want to talk you through is working out the volume of other prisms, so different 3D shapes. And for any of those, really what all we do for any prism, including the ones we've looked at, is look at the cross-sectional area times the length. Okay, that's very easy to do for cylinders or cuboids, and it's just an easy formula to use. For the rest of them, we just use this general formula of cross-sectional area times length. What we mean by cross-sectional area is we mean the area of the face of the prism. Okay, so this is a triangular prism. So just remember, the formula for a triangle is height times base times 0.5. So whatever the area of this is, you'd multiply it by the length, and that would give you the volume of the prism. Okay? So once more, I want you to try. I've got a triangle there with a base of 5 and a height of 7. The length of the prism is 12 centimetres. And I've put the 2 steps that you need to do. So once again, you can pause this video and then have a go at working out the length of that prism. And the answer for that, I've just got down here. So the first thing you want to do is 5 times 7 times 0.5. That gives you the area of the triangle, which is 17.5 centimetres squared. And then you times that by 12, giving you 210 centimetres cubed. Okay? And I figured just as a last thing to do before I set you your work is to do an example using an everyday item. This is a foam roller that I use to stretch after I exercise. It's really important to keep on exercising during this time. Hope that you'll find some time to do that. So this is a perfect cylinder shape. So what I'm going to do is I'm going to work out the volume of it now, the 3D shape. So first of all, if you look at the diameter of it, so I make the diameter about 14 centimetres, okay? Meaning the radius is 7 centimetres. The height of this, it's a bit above the camera, but the height of this is only 1 centimetre shorter than my ruler, which is a 40 centimetre ruler. So I've got a radius of 7 and I've got a length of 40. So the sum we want to do is pi times 7 squared times, do it times 39, so 1 centimetre left. So pi times 7 squared times 39. So putting that into my calculator, so hopefully you can see there, it's quite a bit difficult to read it with the glare, but there we go, pi times 7 squared times 39 gives me 6,003.58 centimetres cubed to the nearest 2 decimal places. So there we go, that's the volume of this cylinder. Anyway, there's information on Google Classroom about the work that I want you to do, and there's a hint sheet attached on there as well. Okay, and I'll be contactable by email all the way through the lesson. Okay, good luck.